Hi, this is Mr. Lonergan, and we're going to look at midterm exam practice number 2, question number 2. In the background, you can hear a raging battle in my house. Titans are fighting good versus evil, but we're not going to let that distract us from our main battle today, which is figuring out about piecewise functions. It says, use the graph to help you complete the equation below. F of x equals x plus 1 for some domain, and x plus 1, the quantity squared, for another domain. So let's look closely at the graph and see if we can see the transition point. One part of the graph should be a linear function. One part is going to be a quadratic function. Hopefully it's easy to see that this point right here is the break point. This section over here is my quadratic, and this section right here is my linear. So the first part of this problem is just describing what part is the orange zone and what part is the blue zone. Because remember, when I'm setting up a piecewise function, I want to say where is the rule, and then the second part is to describe where the domain is to go along with that rule. Before I answer this, I want to come back to the picture and make an assumption. I think, because I am the teacher, I bet the teachers really meant to have arrows on the far left and the far right part of this graph. Because without those arrows, I'm not really going to be able to tell the whole story of the problem later on. So go ahead and draw those arrows in on your graph. And now when I describe the orange zone, I'm going to think about the where does it transition? Well, this is 0, and then this is -1. -2, -3, -4. So that -1 is the maximum value for the orange zone, and because there's an arrow there, the minimum for the orange zone is -infinity. So for the linear section of my rule, I'm going to say it, one way would be to say it like this: -infinity is less than x, which is less than -1. Other way I could say it, just to be a little bit more efficient, is just to get rid of the infinity and just say it x is less than -1. Good. Now let's look at the blue zone. Blue zone starts at -1 and then it goes 0, 1, 2, and because there's that arrow there, I know it keeps going. In this case, the minimum is -1 and the maximum for this zone would be positive infinity. So I can write that like this: -1 less than x less than infinity. Or if I'm being efficient, I can just write it like this: x greater than -1. Now, there's only one little small piece that I've missed, because I've got x greater than -1, I've got x less than -1, but I don't have x equal to -1. And the truth is, for this particular problem, since they meet at that spot and it's the same coordinate for both, it doesn't matter which rule I use for -1. If I plug in -1 here, -1 plus 1 is 0. If I plug in -1 here, -1 plus 1 is 0 squared, which is 0. So either one works, but I just need to choose one of them to include -1. To just make myself happy, I'm going to include it in the second rule. Could have put it down here instead, but I'm not allowed to put it in both places. So I just write that x is less than or equal to -1 on the top rule, top domain, and x is greater than -1 for the bottom domain. Part B says, now that you have the equation, complete the data table below. I've got x values, and I need to look at the rule or the graph to figure out what the y values are. -4 is pretty easy. I look at my graph and go over x equals -1, 2, 3, 4, and look at where my y value is. You can see it's right there, which is a y value of -1, 2, 3. Beautiful. The other ones get a little trickier. When I go over to +1, 2, 3, 4, I try to go up and see that on my graph, but my graph goes up so fast that I can't see it. So instead of using my graph, I'm going to have to use my rule. Is positive 4 in the orange zone or the blue zone? Because it's greater than 1, greater than negative 1, it's going to be in the blue zone. And when it's in the blue zone, I'm going to use the blue rule that says x plus 1, the quantity squared. So I'll plug that in. 4 plus 1, the quantity squared. 4 plus 1, 5 squared. And so I get an n value there of 25. When x is 4, the y value that goes along with that is 25. The last two are more of that same kind of practice. Negative 10 and positive 10. Well, negative 10 is over here in the orange zone. It's less than negative 1. And positive 10 is in the blue zone because it's greater than negative 1. So I'm going to use a different rule for each. I'm going to look at negative 10 and use my linear rule. Negative x value plus 1. Negative 10 plus 1 equals negative 9. And that's what I plug in there for the y value. Positive 10, I have to use this different rule. The input plus 1, the quantity squared. 10 plus 1 is 11. 11 squared is 121. All right. Lots of work, but now we're done with question 2.